Okay, so good morning, everybody. I'm going to start with an announcement. Volume's very high. Just a second while I adjust the volume. Is that better? Okay. Is that better? All right, we'll try that. So the announcement I have is that you have a quiz next week on Wednesday. So the quiz is in class. I mentioned this briefly before on the first lecture. Quiz is in class. There is a sample quiz on OnQ already. So it's been there since the beginning of the course. So if you go to here, I think? No. Sample exam. There you go. So quiz 1 from fall 2022 is here. Quiz 2 from fall 2022 is also here. So the sample quizzes that are there, they're not, so you shouldn't expect your quiz to look exactly the same as those, right? You might not even have the same kinds of questions, right? The sample quizzes are there to show you the relative degree of difficulty that you should expect, right? If you've programmed in Java before, quiz 1 will not be terribly difficult for you. Yeah, anybody have any questions about the quiz? It should be, I'll post exact details about what's covered on the quiz. In principle, it can cover up to the material up to and including today. But you won't get a very difficult list question if the list is on the quiz, right? You haven't had an assignment on it yet, so if I ask you anything about it, it'll be a relatively straightforward question. Yes? You have to speak louder, I can't hear you. Yeah, so no questions? All right, so we'll carry on with today's lecture. So we were talking about lists in the previous lecture, right? And so this is the slide that we ended up on. This is the slide that we ended up on. So this is just this is not a method, right? This is just a piece of code that takes in a non-empty list T and tries to find the shortest string in the list, right? So of course, to find something in a list, you have to iterate over the elements of the list, right? One way to iterate over the element of a list is to use a for each loop, right? So for each string S in the list T, right, we're going to look at the length of the string, right? So remember, S is the current string in the list. S is a string in the list at the current iteration of the loop. Right. We're going to look at the length of the string, compare it to the current minimum length that we've seen so far. Right. If we've seen if that string S is shorter than the current minimum length string, then we have a new shortest string. Right. Process every string in the list, and then you've got your shortest string. So that's using a for each loop. Right. You can write the same code using a regular counting style loop. Right, so everything's the same except for this line here and that line there. Right, so using a counting style loop, right, I can start at the second element of the list. Right, so that's another subtle difference between this version and the previous version. Right, why can I start at the second element? Because I've processed the first element already. Right, so we looked at the first element. We know the length of the string, the first string in the list. So I don't have to reprocess it. I don't have to start at 0 here. I is going to be the index of the element in the list, right? So the maximum element, the maximum valid index is the size minus 1, right? So I want to go up. The loop should run as long as I is less than the size of the list, right? Each time through the loop, increase I by 1, right? Now, unlike the previous version, right, with the for each loop takes care of getting the element from the list for you. With the counting style loop, you have to get the element manually yourself. Right, so I need to call get to get the ith string from the list. Right, otherwise everything's the same. Right, so this version is very, very, very slightly more efficient than this version. Right, this version processes the first element twice. Right, it processes it once here, and then it processes the first element again inside the loop. Right, this one here processes each element exactly once. Right, and of course we can turn this into a method now. Right, so if you want to write a method, that finds the shortest element, the shortest string in a list of strings, right? Your method would look like this, right? It'd be public. In this case, it's static, right? It returns a string, which is the shortest string in the list, right? Its input is an array list of string, right? Now, the two previous versions I showed you assumed that the list was not empty, right? They both assume that you can get the first element from the list. If the list is empty, there is no first element. Right? So if you're going to write a method that does this, then you should probably check, is the list empty? Right? And if the list is empty, you should indicate to the caller that something has gone wrong. Right? So in this case, I'm going to throw an exception. Right? There's many exceptions to choose from. Illegal argument exception happens to be appropriate in this case. Right? I guess the other alternative here is instead of throwing an exception, you could return the value null. Right? Null in Java means no object. Right? So if you ask for the shortest, string in an empty list, well, there is no shortest string. Right? So another valid approach would be to return null here. Right? If you're going to return null, though, you have to document the fact that you're returning null, because you can't do anything with a null reference. If you try to call a method on a null reference, you'll end up with a null pointer exception. Yeah, question? That's right. Sorry.
Like, can you not just say shortest equals the list T at index, like, 0, for example?
That is at index 0. You mean can I not use the square brackets?
Yeah.
No, the answer is no. That's the problem with the list in Java. Right? That's in a list. It's not an array. If you had an array, then you can use the square brackets. Right? But this is a list. Right? And so if you're using a list, there's no square bracket notation. You must use get and set. Yeah. Right. And otherwise, the rest of the the rest of the code is exactly the same as before. Right. Okay. So what can you use a list for? You can use a list for lots of things, right? So if you ever have a collection of stuff, right, and you want to remember what the elements are, the default choice is to throw them into a list. The general advice is to not use an array. You should use an array list instead, right? The array list is much more flexible than an array in Java, right? So, and it's almost as fast as a plain old array. So, if you ever have a collection of stuff, then normally the first type of collection you think of is an array list in Java. So I just want to solve a simple little problem using a list. You could also do this with an array. I'm going to use a list. Right? I want to know what are the odds of rolling the values 2 through 12 using a pair of fair six-sided dice. Right? So what are the odds of rolling a 2, a 3, and so on and so on and so forth. Right? If you've done any basic probability or statistics, you know how to solve this problem. You probably know how to solve this problem without relying on computation, right? You can actually figure out exactly what the odds are. Right? So here I'm just showing you what the odds of each thing are, right? So to roll a 2, right, there's roughly a 3% chance that you roll a 2. 7 is the most common value that you would roll using 2 dice, and so that's roughly 17%, and so on and so on and so forth. Right? So if you didn't know how to compute the odds, using statistics, right? You could simulate the process, right? And so this class random that you should have encountered if you've started assignment 2 already, right? So if you started assignment 2, you've run into random, right? That thing random lets you make random true-false values, random integer values, and random floating point values. Right, so basically random numeric values. Exactly how it does it is well beyond the scope of this course. Right? If you click that link, though, that will tell you how it does it. At least that'll tell you how Java 8 used to do it. I don't know if the most recent version of Java still uses this thing. If you're interested in this sort of thing, this is like graduate level stuff. Right? So it's not generating random numbers is not something you would look at normally in an undergraduate course. or how you generate them is not something you'd normally look at. Right? So to simulate this thing, right, what you would do is you would write a little computer program, and you would just roll a whole bunch of pairs of dice, right? So you just keep on doing it for some period of time, for some number of times, right? And then you would count the number of times you rolled a 2, the number of times you rolled a 3, and so on and so on and so forth, right? So in other words, one way that you could solve the problem is as follows, right? I'm going to make a list, right? And I'm going to add 13 zeros to the list. So what I want to do is I want to make this table here, right? I want to make that table. The sum, right, I would like that to be the index for my, for the list, right? So the index 2 of the list would be the number of times I rolled a 2, right? Index 3 would be the number of times I rolled a 3, right? Index 12 would be the number of times I rolled a 12, right? So 12 is the maximum value, so I need a list of size 13. Right? So I'm going to make a list. I'm going to add 13 zeros to the list. Right? Then I'm going to simulate rolling a pair of dice n times. Right? So roll 2 dice, sum their values to get x. Right? So x is the value that I just rolled. I'm going to go into my table. Oops. Right? So suppose I rolled a 5. Right? I'm going to go into my list, look at the element at index 5. Right? Now remember, this is going to be the number of times I've rolled a 5 so far. Right? So I'm going to get whatever that value is. Right? I'm going to add 1 to it, and I'm going to put it back into the list. Right? So add 1 to the value at index x in the list. Right? If you want to compute the odds or probability, right, after you've done all of this, right, you can take each value in the list and divide it by the number of times you rolled the 2 dice. Right? And that will give you the estimated odds of rolling a 2, 3, 4, and so on. Right? And so what does it look like in Eclipse? It looks like something like this. Do you want me to do this from scratch, or do you want me to just look at the code? So I can erase all this and we can go through one line at a time. Who wants to do it that way? Anybody? Do we just want to look at the code? Oh, we want to do it the first way? Yes? Okay, let's do it the first way. So I'll nuke all this. We can do it one line. We'll do this one step at a time. All right, so I want to make a list, right? How do you make a list? Well, it's just array list. Right? Okay, so I need the type of element in the list, right? If I want to store the count, then I can use integer, right? Or long if you wanted to, right? If I want to store the odds, I would use double, right? So it doesn't matter how you choose to solve the problem here, right? I'm going to do the count. So let's use a list of integer, and we'll call it count. I want to make a new empty list, right? So that's new, array list, boop, boop, like that. Right? So there's my empty list. Right? I now need to add 13 zeros to the list. Right? So I could write 13 lines of code, but it's better to use a loop. Less than 13. Some people will complain about the 13 here, right? They'll call that a magic number, right? So a magic number is just a number that's not 0 or 1 that shows up in your code somewhere. It's called a magic number because usually they're undocumented and people have no idea what they mean, right? So if you really wanted to, right? So if you're being really, what's the word I want? Conscientious about how you do this, right? Define the maximum roll. So the maximum roll value is a constant, right? It's 12, right? So if you want a constant in Java, you are allowed to call it, you are allowed to declare the variable as being final. Right? So that, right? So that declares a variable of type int. It's called max value. Its value is 12. Right? Final means that I can give max value a value exactly once. So there's where I assign the value to max value, right? If you don't give it so you have to give it a value before you use it, right? When you give it a value, you can only give it a value once, which is what final means, right? So in other words, you can't try to assign a value twice to max value, even the same value, right? So a final primitive value is always constant, right? And now here you would write max value plus 1. Personally, if I knew that you were solving this problem, I would just use 13. But anyway, a lot of people will tell you you should actually name your you should name any constant values in your program. All right, so I now want to add the value 0 13 times, right? So there you go. Right, so the add method adds a value to the list, right? It adds a value to the end of the list. So that adds 13 zeros to my list. Can you use fill? It depends which version of Java you're using. So if you're using Java 8, there is no fill, but more recent versions of Java have a fill method. Yeah. So there would be, I think it would be list.fill is the method name. I don't remember. But yes, I think there is a fill method somewhere. I guess we should look. Why don't we look? Java list. So I probably need a version higher than 8, because I know there isn't one in 8. So let's see what we have. So this is version 20. There's an add. There's no fill here. There's an of, but there won't be an of that takes in 13 values. Remove all, replace all, retain all, to array. All right. So the next place you would look is inside the collections class. So if you ever want a method that operates on a list or something else, which I'll tell you about later, and it's not in the list class itself, you can consider looking inside collections. And so if we look at collections, is there a fill? There is, right there. So you could use fill from collections. Places all the elements. Oh, actually you can't. So fill, oh yes, this is the problem. So remember how a list works, right? So a list holds a variable number of elements, right? So this particular fill method takes a list and sets every element of the list to that value there, right? So you'd still need 13 values in the list in this particular case, right? So in this case, I think not the only, I shouldn't say the only way. The most convenient way to do it is the way that I just did it, the way that I just showed you. There's probably a shorter way to write it, but it relies on knowing more about the Java language than we get to in this course. All right, so what's the next step in my algorithm? I want to make my list, repeat the following n times, okay? So n is another one of these Control Z. N's another one of these constants, so final int n. Let's do it 100 times. Right. I'm going to repeat the process. So I'll put in the comment here for you. Roll the pair of dice n times. All right. So if I'm going to do that n times, I want to loop. Okay, so I now need to roll a pair of dice, right? So rolling a pair of dice is generating a random number. So I now need a random object in order to generate the random number. I can make the random object inside the loop, right? That would be, it would be correct. It would be inefficient, right? Because I'd be making a new random object every time the loop ran. Right? So for example, you could write random like that, right? So the class random, I guess it imported it for me automatically. Oh, it's already here because I deleted some code, right? So you have to import that, right? So I can make the object every time, right? But there's no need to make a new object every time, right? I can reuse the same object each time. Oops. Control, copy, Control V. There we go. Right, so that would be preferable in this case, right? Don't make a new object every time, just reuse the existing object. Right? And now I want to roll the dice twice, right? So int, I'll call it die1. So RNG, so I need the method that generates a random integer value between, ideally between 1 and 6, but there isn't one, right? So there's this method called nextInt, and it takes in an integer value that is the bound, right? So if you read the documentation for the method, it tells you that this method generates a random number between 0 and bound -1. So in other words, next int 6 generates a random number between 0 and 5. I want a random number between 1 and 6. So what do? You add 1. Right? Easy peasy. Right? Again, if you're being very conscientious here, you might want to create another constant, which is the number of sides on the die. Right? So I don't know. Sides equals final int sides equals 6. Yes.
I think there is a method where you put in the origin and
There might be one so I only remember things from Java 8. So it's possible that they have updated the class so that it does something else now. Am I in the right class? Package, no, I'm in the wrong. I don't want this package. I want the class. So the problem with Java is, one of the problems, is that the company that runs it now, or is responsible for its evolution, has decided to change things every 6 months. So the language evolves very rapidly, which is super annoying when you're trying to teach it. Because you write up some code in some version of the language, and then later on, they make some change, and it turns out there's a much easier way to solve the problem. So, int, not that, next int, okay. So there's a next int, where's next int? Next int, and there's a next int that takes in a bound. I don't know if there's one that takes in both. Next int, origin bound. Oh, there you go. So there is a version that takes in the starting value and the specified bound. So you could use 1.7 in that case. Right? Okay, the second die is exactly the same thing. Sorry. You get a number between 0 and 6. So now your die is rolling zeros, which is unusual. Right? Right? So if you put in 7, you get a number between 0 and 6, which is no good. Right? You want 1 and 6. Right? So generate a random number between 0 and 5, add 1. That gives you 1 and 6. Right? So finally, the sum. I think I called it x on the slide, so I'll call it x here. That's the sum of the two dice. I want to go into the list and get the number of times that I've rolled the value x. Right? So int num x. Right? So that's going to be count get x. Right? Now I just rolled x one more time, so I want to add 1 to num x and put it back in the list. Right? So count set x num x plus 1, like that. Okay, so I'm not going to do the division right now. Let's just see what happens when we print out our list. So you can print out the list just like that. So if you want to print anything in Java, you can just plunk the variable down, and Java will try its best to print out that thing there. Right? Exactly how it does it, we'll look at in a couple of lectures. Right? But you can print a list. So we rolled the dice 100 times, and we see that we get 0 zeros, right? 0 ones, 3 twos, and so on and so on and so on and so forth. Right? So if you want the odds, take the count and divide each value by the number of times you rolled it. Right? And we'll print it out in a slightly nicer way. Right? So for int value equals, so I can start at 2 because I don't care about 0 or 1. Right? Value is less than max value, less than or equal to max value. Right? So let's print out the value and then print out the value divided by n beside it. Right, so system value. Yeah, okay, so I want to print out the value and then the value. Okay, so double, odds. Okay, so what I want to do here is I want to get the element from the list. Right, so count, get value. Right, and I want to divide it by n, like that. Right, and then I want to print out the value, followed by, so I want a space of some kind here. I'm going to put in a tab instead of a space. So \t, that's your tab character on your keyboard. Right? The tab character, if you don't know what it does, it will advance the position on the line to the next what's called tab stop. Typically on a terminal like this, it'll be 8 spaces. Right? So the first tab stop is at column 0. The next tab stop's at column 7. Yeah, 7, every 8 spaces, right? The next one is 8. 8. The next one is at 16, and so on and so on and so forth. And then I want to print out the odds, like that. Okay, so try that. And let's look at the result. Okay, so it looks like the odds of rolling a 2 are 0. Well, that's not good. 3, 0. They're all 0. But the counts are not. Right? The counts are clearly not 0. Right? So if I take 2 and divide it by 100, I would expect 0.02. Instead, I'm getting 0. Right? And so what's the problem? Anybody see the problem? Yeah. That's right. Right, that line right there, right? So remember, count is a list of integer. So when I get the value out of the list, it's an integer. Right? If I divide by n, well, n is an int, right? N's an int. Right? So the compiler auto unboxes get the count.get value, turns that into an int. Right? That divides by another int. Right? And in this case, you get 0 for every value. Right? How do you solve the problem? You have to tell the compiler, hey, do this with floating point division instead. Right? What's the best way to do this? There's lots of ways to do it. I almost always write 0.0 plus. Right? So if you write a double value plus the count, plus the value from the list, right? That forces the compiler to do the arithmetic using double. Has to be in round brackets here because you need to do that sum before you do the division, right? Because division has higher precedence over the sum. And now that will be a floating point value, or the correct floating point value. Right? And there you go. Right? So 0.2, 0.05, 0.08, 0.06, 0.11. Right? And if you look at the table from the slide, right, you'll notice that they don't match up exactly. Right? We got 2% instead of 3%, right? The next one was 3% instead of roughly 6%, and so on and so on and so forth, right? And so whenever you simulate something, so whenever you simulate a random process, right, the number of times that you simulate the process affects the accuracy of the final result, right? So in this case, what you want to do is you really want to run this an infinite number of times. So that if you run it an infinite number of times, that will actually, assuming you could, it would give you the correct, it would give you the exact odds. It would give you the exact odds. The problem is it would take an infinite amount of time. So you need to use some large-ish value here for this relatively simple problem. Right? As soon as you use 10,000 values, you start to get values that are very close to the true odds. Right? If you're running a much more complicated simulation, so for example, if you're simulating climate, right, the number of times you have to run the simulation to get a decent result is very large. Right? But that's just the nature of the beast. All right, anybody have any questions about that little example there? Yes? Why we used? Here. Okay, so you have to look at what next int says it does. That's the problem with programming, right? You always have to go and look, what exactly does this method do, right? And so if you look at what class am I in? Oi, sorry. I am in, all right, I want the random. Okay, so when you go look at the next int method for random, right, so first of all, there's two of them, right? The first version returns a random number between 0 and, in this case, it's between 0 and integer dot max value, right? The second version, which takes in a bound, that's the one I'm using, right? So that one says it generates a random number between 0, inclusive, right, and the specified value, exclusive, right? So in other words, it generates a value between 0 and bound minus 1, right? So back in Eclipse, I would like to generate a random number between 1 and 6, right? So if I just write that, I get a random number between 0 and 5, right? If I had 1, I get a random number between 1 and 6, right? If I use a 7 here, right? If I use 7 for 6, I get a random number between 0 and 6, but that means I have a 7-sided die, which isn't what I want, right? I don't want to roll 0, right? I can only roll a 1 on the die, right? That's the reason why that's there. You're going to find that a lot happening in many programming languages, right? There's going to be some parameter that you pass in, like a bound in this case, right? And the value that's generated is the bound minus 1, right? Same thing happens in a sublist or in a Python slice, right? That second number you pass in is always 1 larger than the stopping value of the stopping index of the slice, right? It's very common in many programming languages. And yes, question.
So the last time we printed our maximum was built that we see that there's 13 values in the list.
13 values in the list. That's right, right? So we're using the index for the value, right? Right. So the index corresponds to the value that I've rolled, right? So there is the value at index 0 should be 0. I can't roll a 0 with 2 dice, right? The value at index 1 should be 0. I can't roll a 1 with 2 dice, right? But 2 through 12, I should be able to roll with 2 dice, right? Yeah, that's the slightly confusing part in this example. Yeah. Any other questions? All right. Okay, so you can do a similar thing for flipping coins, right? So if I flip a fair coin n times, right, how many heads do you expect to see, right? So if you flip it n times, you probably expect to see n over 2 heads, right? But every once in a while, but you will also, if you do this over and over and over again, right, there will be some number of times when you see 0 heads, some number of times you'll see 1 head and 2 and so on and so on and so on. Right? And so you'd like to make the table that looks like this, right? Flip a coin n times, right? How many times should I expect to see 0 heads? How many times do I expect to see 1 head? How many times do I expect to see 2 heads? And so on and so on and so forth. Right? This is very similar to the previous example, right? Again, you can compute this if you know how to do this using statistics, right? If you want to do it via simulation, then you write a little computer program that flips a coin a whole bunch of times. So again, make a list, add n plus 1 zeros to the list, right? Why n plus 1? I'm going to flip the coin n times, but I might see 0 heads. So in total, there's going to be n plus 1 rows in the table. Right? I want to do this experiment many times, right? So I'm going to repeat this m times. Right? I'm going to count the number of times that I see. Count is going to be the number of heads that I see, right, when I flip the coin n times, right? So now flip the coin n times, right? If I get a head, add 1 to the count, right? So that simulates the process of flipping a coin n times, right? I'm now going to go into my list, right? Look at index count of the list, right? And add 1 to whatever value is sitting there, right? Almost exactly the same as the previous example, except now there's a nested loop. Right? If you want the odds, divide each element in the list by m. Right? Again, making sure that you do the division using floating point arithmetic. Where is the dice? Wait, dice. Oh, dice. Where's the coin? Oh, I don't have the coin one here. Okay. I guess we'll do the coin one. New class. So I guess we'll call this coin. Right. I would like a main method here, so I'm going to click that box there. Click finish. All right. So make a list. I'm going to store the number of times I see a value, so that's a list of integer. Oh, you know what? Let's do this with double. So I'm going to compute the odds. Am I going to post this? I mean, I could. I shouldn't have to, but I could. Okay, so notice that when you use array list for the first time, right, Eclipse is going to complain. Right? Get a little error. It's going to say, Eclipse is complaining, I don't know what array list is. Right? So you have to import array list. Right? Now, usually it'll give you, sometimes it'll give you multiple options. So what you have to be careful of is to make sure you pick the right class. Right? So there might be two classes named something inside the Java standard library. Right? They have the same name. You have to make sure you pick the right class, otherwise it gets very confusing. There's only one array list, so I can just click that one, right? And it adds the import statement for you. I need to add, I need to decide on my value of n. So final int n. So n is the number of, n is the number of times, to flip a coin. Right, so we'll do 20. So I now need to put in 21 zeros into my list. Right, so a little for loop. I is less than or equal to n, I plus plus. Right, you could also write I is less than n plus 1. Right. Sorry. Odds, I want to add a 0 to the list, so add 0.0. Right, so that puts my n zeros into my list. Right, and I now would like to flip the coin. I would like to perform the coin flipping experiment m times. Right, so number of trials. Right, so final int m. So let's do about 10,000 again. Right. Write a little loop. Right. Okay, so now flip the coin n times. So again, another loop. Hey, for I equals 0, I is less than n. Okay, so how do you flip a coin now? Well, I need a random number generator. Oh, wait, sorry, I can't use I again. J. Okay, how do I flip a coin? Well, I can need a random number generator. So again, I don't want to create the random number generator anew every time through, in this case, 2 loops. So I'll make it outside the loops. Right. And inside the loop, it's a Boolean. So I want to, true will be heads, false will be tails. Right, so flip equals RNG. So the random number generator has a method called next Boolean, right, that returns randomly true or false. I also need a count, so I need to count how many heads I flipped, or how many heads I flipped, right? So before the J loop, right? You can't put the count inside the loop, right? Because the count gets reset to 0 every time, right? So I have to declare count before the loop, right? So if flip is heads, right? So I could write if flip equals true, right? But flip is just a Boolean value, so I can just write if flip, right? then the count goes up by 1. What's going on here? So it's complaining, that's fine. So after I flip the coin n times, I want to go into the list and see how many times have I seen that value. Right? So int, I guess what did I call it before? Sorry, I just want to be consistent with my previous numx. Okay, so I'm going to call this numheads. So this is going to be the odds dot get count. It's going to complain, right? So why is it complaining, right? Because odds is a list of double, right? I'm not keeping the count here. I'm trying to compute the odds directly. Well, sorry, I'm eventually going to store the odds in the list, right? So I can't put a double into an int. So you've got two choices here, both of which are okay, right? I can either call numheads a double, right? Or I can leave it as an int and take this result and cast it to an int, right? So in other words, I can leave that as an int and tell the compiler that I want to treat this double value as though it were an int value, like that, right? And that should, oh wait. It's going to complain again, isn't it? Yes, it's going to complain again. Right. So that's what I'd like to do. It's still complaining. Right. So what's it complaining about? It says, if you can read it, it says cannot convert from big D double to int. Right. So remember that in our list or our array list class, right? When you specify the type of element, right, it always has to be a reference type. Right. So in other words, it can't be a primitive type. So this list is a list of big D double, right? It's not a list of little d double. So when I call get, I get a big D double object, right? You cannot cast a big D double object to a primitive int, right? I can cast it to a primitive double, but I can't cast it to a primitive int. Right? I can't even cast it to a big I integer object either. So that doesn't work either, right? So what is the solution here, right? So the solution is temp. So if you really want to treat this value as an int, then the number of heads like that. Okay, so now that you've got the number of heads, I can go into the list. I can update the number. I can add 1 to the value and put it back in the list. Right? So odds set count heads plus 1. Right? Because I just that's after flipping the coin n times, I've now got that number of heads. And what's it complaining about here? The method set int double of the type is not applicable for the arguments int int. So now it's complaining about this thing here. Right? It's now complaining you're trying to put an int into a list of double. Right? So now you have to convert this back to double anyway. Right? And now it's happy. Right? So in this particular case, all of this conversion back and forth between int and double, it's not really worth it. Right? It's much simpler if you just write and then odds right? And this saves you the trouble of having to repeatedly cast back and forth to make the compiler happy, right? So yes, the number of heads really should be an integer value, right? It's a count of some kind, right? But in this particular case, it's much more convenient just to treat the number of heads as though it were double, right? Oops, sorry, that semicolon shouldn't be there, right? Which prevents the casting back and forth, right? Again, this is another artifact of the, this is another consequence of the fact that you can't make a list of primitive type. Okay, so there are my odds. Those aren't quite the odds, right? So to compute the true odds, I have to take every value and divide in the list and divide it by m. Right? So one more loop here. I is less than or equal to n. Odds set I, odds get I divided by m. Oop. Odds is, yes, that's correct. What's the problem here? Oh, but for I, got a misplaced brace. Expected, what did I do wrong? There, if the flip, there, there. Oh, sorry, I'm nested over one too far. Is that true? Yes, I am. Okay, sorry. There we go. And now finally, somewhere I lost a brace. Okay. And let's just print out the odds directly, like that. Okay, so save your work, run the program, right? And if we look at the results, right? So it looks like that when we did this experiment, we never saw 0 heads, right? So remember, we're flipping the coin 20 times in this case, right? And we never saw 0 heads. We saw 1 head a very small number of times, right? Somewhere in the middle, you should see the maximum value, which will correspond to roughly 10, right? Which is, oh, sorry, that one right there, right? And of course, if you wanted to print this out in a nicer way, right, you would write a little loop. Well, let's write the little loop. Oh, you know what? Why don't we just print it out here inside the loop? So system out print line. So we're going to print out the value of I. And plus odds get I. Okay, that'll be a little bit easier to read. Right. And now you can see that 10 is in fact the largest. The chance of seeing a 10 is the most, yeah, so the chances of seeing 10 heads is the highest out of all the possible values, right? You can see here that we never saw 20 heads or 19 heads or 18 heads, right? Which isn't correct, right? If you do this experiment enough times, you should see, there should be some small but finite probability you see 20 heads if you flip a coin 20 times, right? Again, it's this value of m that controls whether or not you see the accuracy of the final results, right? So if I make m bigger, much bigger, right, you should start to see, yes, so there's now some non-zero probability that you roll 20 heads, or you flip 20 heads. There's still only, in this particular case, we still never saw 0 heads, right? So again, the accuracy of the simulation results depends on the number of times you run the simulation. All right, so that's basically all the time we have. Anybody have any questions about the 2 examples that we worked through? No? All right, so I guess we're done for today. I'll see you on Friday morning.